In simple terms, twinkling of stars is caused by the passing of light through different layers of a turbulent atmosphere. Most scintillation effects are caused by anomalous atmospheric refraction caused by small-scale fluctuations in air density usually related to temperature gradients. Scintillation effects are always much more pronounced near the horizon than near the zenith directly overhead, since light rays near the horizon must penetrate a denser layer, often have longer paths through the atmosphere before reaching the observer. Atmospheric twinkling is measured quantitatively using a scintillometer. The effects of twinkling are reduced by using a larger receiver aperture. This effect is known as aperture averaging. While light from stars and other astronomical objects are likely to twinkle, twinkling usually does not cause images of planets to flicker appreciably. Stars twinkle because they are so far from Earth that they appear as point sources of light easily disturbed by Earth's atmospheric turbulence, which acts like lenses and prisms diverting the light's path. Large astronomical objects closer to Earth, like the and other planets, encompass many points in space and can be resolved as objects with observable diameters. With multiple observed points of light traversing the atmosphere, their light's deviations average out and the viewer perceives less variation in light coming from them. Though it wouldn't work so well in the nursery rhyme, there is actually a technical term for when stars twinkle: astronomical scintillation, an effect due to our planet's atmosphere. As light travels through the blanket of air around our planet, it is diffracted, bounced around, causing a quick apparent dimming and brightening, a star's signature, twinkle. While some stars do physically change in brightness over time, they typically do so on long time scales. Amateur astronomers monitor these changes sometimes over hours, but more often over days, weeks, or years. These variable stars are well studied and often signal complex physical changes happening to the stars in question. The more rapid changes of scintillation, on the other hand, come about long after the light has left the star. Light waves traveling through Earth's atmosphere diffract as they pass through pockets of air at different temperatures. Because the light waves come from a single point, this effect can make the star's brightness and position appear to change. Why don't planets twinkle too? Unlike stars, planets don't twinkle. Stars are so distant that they appear as pinpoints of light in the night sky, even when viewed through a telescope. Because all the light is coming from a single point, its path is highly susceptible to atmospheric interference, i.e., their light is easily diffracted. The much closer planets appear instead as tiny disks in the sky, a distinction more easily discerned with a telescope than with the naked eye. Their apparent sizes are usually larger than the pockets of air that would distort their light, so the diffractions cancel out and the effects of astronomical scintillation are negligible.